All right, welcome pre-algebra students. We are talking about lesson 61 today, and we're going to be solving equations in two steps. Up until now, we've been solving single-step equations like this. X over 3 is equal to 2, and we would use the inverse operation and say, well, if this is division, if I turn around and multiply, right? But if whatever you do to one side, you have to do the other side. 3 times a number divided by the number makes these two cancel, so that would be x is equal to 2 times 3, which would be 6. Or you might have a problem like this: x plus 2 is equal to 8. Well, when we subtracted 2 from both sides, we would find that x is equal to 6, right? Or maybe you had a problem like this: 3x is equal to 18. Well, this is multiplication, so the inverse is division. When we divide both sides by 3, we get that x is equal to 6. Or maybe we had a problem where x minus 3 is equal to 3. We would add 3 to both sides, and we would find that x is equal to 6. These are all single step. Now we're moving on to multiple step equations, and we're going to start with 2 steps. So let's jump into some of our example problems. This is example 61.1. Let's start with 3x plus 2 is equal to 7. Our first step would be the one that you would automatically think of, and that would be to take this positive 2 and subtract 2 from both sides. And that would leave us, these two would cancel. We draw our line, and that would be 3x, because this would be 0, equals 5. Well, now our second step is going to be undoing this operation. So this is multiplication, so we undo it with division. So the answer is x is equal, I don't know why I wrote a 5. That should be a 3. X is equal to 5 over 3. All right, let me make this clear. Pre-algebra students, do not plug this in your calculator and give me a decimal. This is the answer. The answer is the fraction. In algebra, you've got to start wrapping your mind around the fact that we prefer a fraction to a decimal in algebra. Algebra, when we see a fraction, we can actually resolve it easier than we can a decimal. Do not divide this number. Leave it the way it is. This is going to be the proper answer. It's a more succinct and a more accurate answer, because this is going to end up being a non-terminating repeating decimal. We don't like those in algebra. In algebra, those are irrational. This, however, this is it. This is the final number when you just leave it in a fraction form. So the fraction is easier to manipulate, it's easier to factor, it's easier to transfer from one place to another because you don't have this long string of decimals in behind it. Stop giving me decimals, okay? Unless the question asks for a decimal, leave it in a fraction. All right, example 61.2. We have 2 over 3 x minus 1/2 equals 10 over 3. All right, so we need to get rid of this. So we're going to add it to both sides. All right, so this becomes 2 over 3 times x is equal to, and we need to bump these up to have a common denominator. So this needs to be multiplied by 2, so it's going to be 20 over 6 plus 1/2 is going to be times 3, so plus 3 over 6. So it's going to be 23 over 6. So I'm going to erase this part. and I'm going to make this 23 right here. 23 over 6, right? So now what I want to do is do the inverse operation here. I have 2/3 times x. So what I want to do is use the reciprocal of this fraction. So I'm going to say 3 over 2 times x. Now how does that get rid of this? We don't like a fraction next to our variable. What happens is this becomes 3 times 2 becomes 6. 2 times 3 becomes 6. 6 over 6 times x. This reduces to 1x, right? And we know when we have x by itself, there's always that invisible 1. So that is why we use the reciprocal to multiply against, so that this will go away and reduce to 1. So that's why we use the reciprocal fraction and multiply. But now here's the thing. If we do it to this side, we also have to do it to this side to keep this equal statement true. We have to keep the balance. So while this cancels out over here and becomes 6 over 6 is 1x, we have to do it over here. 23 times 3, but this right here is factorable, right? We know that we could factor this into 2 times 3, which allows us to get rid of this 3 and this 3. So now we have 23 over 2 times 2. So 23 over 4 is our answer. All right? Leave it a fraction. I do not want a mixed number. I do not want a decimal. You want to keep it a fraction. All right, let's do 61.3. We are given some mixed numbers here. 2 1/3. X minus 1 1/5 is equal to 23 over 10. All right, now the only thing I dislike more than decimals is mixed numbers. In algebra, we do not like mixed numbers either. We rather would have a whole number or we want a fraction. We don't want both, and we don't want a decimal. So what we do is we turn this back into an improper fraction. An improper fraction in algebra is always better than a mixed number. 2 times 3 is 6, plus 1 is 7. 7 over 3x. Minus 6 over 5 is equal to 23 over 10. All right. We're going to add 6 over 5 to both sides. But when we bring it over here, let's go ahead and change the denominator to 10. So this is going to double. So that's going to be plus 12 over 10. All right. If you don't know where I got 12 over 10, times 2 times 2. We know if we multiply the top and the bottom of a fraction times the same number, it keeps the same value. So that's what we did, and we just made it 12 over 10. So this is going to end up being 7 over 3x is equal to 35 over 10. Let me scroll this up a little bit so we have more room. All right, so now we know that this is reducible. We can reduce this fraction by 5s. So 35 divided by 5 is 7. And 10 divided by 5 is 2. Okay, so that's reduced. Now we're going to take this and we are going to use the reciprocal to multiply so that these two will cancel out. But we have to multiply on this side as well to keep the balance, right? So 21 over 21 becomes 1x. So x is equal to, and we have 7 on top, 7 on the bottom. Those cancel out. We factor them out. Our answer is 3 over 2. Leave it like that. All right, let's see if we have any more of these problems. Nope, that is all we have for lesson 61. So look at what you have. Figure out what steps you need to take. If you have a mixed number, the first thing you should do is turn it into an improper fraction and worry about that first. Then if you have an x term and another term, you need to swim this other term over here. We swim it by doing the opposite sign to both sides. If you need to change the denominator as you do so, change the denominator, okay? Then if we have a fraction next to our variable, we multiply both sides by the reciprocal fraction so that they will cancel out, because 3 times 7 over 3 times 7 is the same number. That's why we do it. But if we do it on this side, we have to do it on this side to maintain this equal sign, to keep it balanced, right? Factor if you can, and then give us the answer. If it's an improper fraction, leave it as an improper fraction, okay? If it's a fraction of any kind, leave it as a fraction. However, if you can reduce that fraction, reduce it. Not into a mixed number, just from a factorable position. So if you had 4 over 8, reduce that to 1 over 2, right? That's what you would want to do. If we can reduce a number, we reduce a number. Or I should say a fraction. All right, that's all we have for lesson 61. I'll see you in lesson 62.